Okay, so guys, we're going to talk about vectors today. Entitle your notes vectors. And we'll start off with a formal definition, okay? So a vector is an ordered pair okay, but it looks a little different. You know how when we use ordered pairs, guys, we use parentheses? Okay, these are like a less than and greater than sign. So it looks like this. And the reason is because it doesn't actually mean a spot on a grid, right? A normal ordered pair, for example, if I had told you like 3, 2, that would mean, right 3 up 2, and it'd be a spot on the graph, okay? A vector doesn't have those parentheses. It's got the little less than and greater than sign because it actually is different. A vector measures two different things, okay? It actually measures magnitude and direction, okay? Right, so it's got both magnitude and direction. Right, and let me show you what I mean by that. Right, if I take a point P to a point Q, if you think about this, there's two ways to go. I can go from P to Q or from Q to P. So it's got, a vector has a direction. So if you're gonna go from P to Q, you're gonna go this way, okay? And the length of PQ actually, it has a length and a direction. Right? And for example, okay, if you go this way, it's going to go what? To get from P to Q, you would have to go right. And then what would you do? Go up. Right and up. If you're going from P to Q. If you're going from Q to P, you would go down and left. So you see why it matters which way you're going, just like an arrow. Now, in order to name a vector, okay, you have to have 2 points, okay? And so even though it's going to look like a point, it's really not, right? You have to have 2 points to even name it, okay? So let me show you what I'm talking about. It takes 2 points to name a vector. And here's the formula for it, okay? The formula calls for x2 minus x1, okay? Then y2, I'm sorry, that's go there. That's the first part. In other words, the change in x. How far am I going to get, in order to get from P to Q, how far on the x-axis am I changing? That's what the first number in a vector is, okay? The second number in a vector is how far you went up and down. So that's going to be y2 minus y1. And that gives you the answer, okay, A, B, or in other words, your vector, whatever you want to call it. So let's actually try. We're going to use PQ and we're going to give it some values. I'm going to tell you what it is. So if I told you that P, for example, is an ordered pair of 2, 1, and we're going to travel to Q, and Q has an ordered pair of 5, 4. I'm going to go from P to Q. That's my vector. So the question will ask you, PQ, going from P to Q. Did y'all see that where it's written? Now, to solve it, you have to kind of think about this for a second. To get from P, right here, okay, to Q, let's look at the x values. Remember, if you look at the formula, that's how far I traveled on the x-axis. Well, if you look at the ordered pair here, in this ordered pair, I'm at 2. In this ordered pair, my x value is 5. So if I was at a 2 and I traveled to a 5, how many x values did I travel? Good, 3. Okay, from 2 to 5 would mean I moved 3 to the right. I was at 2, now I'm at 5. So if you want to mathematically show that, though, you can do this. And I show my kids this, and this is really important because the way this thing works is x2 minus x1. You'll notice that. Order matters. Okay, so which one is x2, the p or the q? Which one's the second point? The q. So when you subtract, I like to put a little arrow this way so I don't forget. It's the q value minus the p value. So in other words, to get that first spot, which you told me is 3 units, I did 5 minus 2, right? Which gives me a value of 3. In other words, this vector has moved 3 spots on the x-axis. Now let's find y, the y value. The same thing. Okay, I'm going to take q minus p. Guys, pay attention, please. Focus. This isn't hard. If you'll listen to me for the next 10 minutes, you'll understand it. But you have to tune in. So then I'm going to take q minus p. But this time I'm talking about y. Well, if you look at it again, if I was at 1 and I went to 4, how high did I move? How far? I moved 3 up. Okay? But if you look, if you do 4, start with the q like it says, and take away 1, that gives you, like you said, 3. So the vector is called 3, 3. And that's because I moved right 3 and up 3. That's why it's called a vector. That's why it's named a vector. The little 3, 3 means to get from P to Q, we're going to go right 3 and up 3. 3, 3 is not a spot on the graph. No, it's a direction. Okay, I went over 3 and up 3. Now, what I didn't say is how far the vector went, the magnitude of the vector, the length, and we'll study that in just a second. Okay? So if you get here, we went over 3 and we went up 3. That's how we got there. Okay, and one really important part, and I already kind of told you this by this little backwards, okay, when I drew this little arrow, when we subtract using this formula, we always start with the second one, right? So x1, y1, okay, is the initial point. Okay, and then x2, y2 is the terminal point. Terminal meaning ending. Okay, so now I named the vector. PQ was named what? What is it? 3, 3, correct? Okay, so the next thing that they're going to ask you for a lot of times is the magnitude, right? So let's write that next. The magnitude or the length of vector AB, okay? And this is the formula to find it. Now, let me ask you a question. Go back and look at this picture. What math formula, and we've done it in pre-cal a lot too, but a lot in geometry, what math formula am I going to use to find the length of that PQ?
Pythagorean theorem.
Yeah, it's Pythagorean theorem. This is a right triangle, correct? So I would take a squared plus b squared, right? In other words, the length here, which in this case was 3 units, right? And then the length here, which in this case was also just happened to both be 3. We would do 3 squared plus 3 squared, and then what would we do to our final answer? what do you always do? You take the square root. Good. Okay, so the formula then is exactly that. To find the magnitude or the length, you take the square root of a squared plus b squared. In other words, you take the square root of the two legs. That's how you find it. So we already decided that PQ, the vector was 3, 3. Okay, it's direction and speed. But now, we want to find the length of it, or the magnitude. And it's written kind of strange. This is how I know. It's written with two absolute value bars, PQ, and then another two absolute value bars. It's kind of weird. So if I want to know the length, or in other words, the magnitude of a vector, this is the way, the form that it's going to be asked in. Okay? And all you do is you just apply the formula. So to apply the formula, I'm going to take this right here, the 3, 3, right? And I'm going to say, okay, it's the square root of a squared, which would be 3 squared is 9, plus 9 more. So the square root of 9 plus 9 is the square root of 18. Now we've talked about this in the past, the square root of 18. If it can be broken down or if it can be simplified, you are required to do that, right? So if you don't know your perfect squares, somewhere, maybe at the top of your page or something, remember, they're like 1, 4, 9, 16, 25. If you think about your perfect squares, is there a perfect square that divides evenly into 18? Divides evenly? What is it? 9. So this is the same thing as 9 times 2. So the square root of 9 is actually 3. So then you take the square root, so 3 root 2. So guys, the magnitude of PQ, the magnitude of vector PQ, in other words, the length of vector PQ is 3 root 2. Okay? All right, now, let's try some more of that kind. I'm going to give you 2 points. So given that A is 4, 2, and B is 9, negative 1. Given that A is 4, 2, and B is 9, negative 1. I want you to find for me vector AB. Okay, do you remember how to find it? How do you find it? What's the formula to name the vector? In other words, what I'm asking you for is how far to the right did it go and how far up did it go? If I'm traveling from A to B, right? And remember, to do the problem, you go backwards. You're going to go this way. See the little arrow I drew? So to find the math, and you don't have to write the math down, but I'm going to show you. So you take B, which is 9, and you subtract 4. That's going to give you how far you traveled on the X. I want 5. Okay, and now to find the Y, you do B minus A, so negative 1 minus 2. That's how far you're going to travel on the Y. So to write the final answer then, the answer is actually 5, negative 3. Okay? So in other words, this vector, to go from A to B, travels 5 right and down 3 to get from one point to the other. Now let's go to B. Part B is going to ask you for what is the magnitude of AB. What's the length of the magnitude? The magnitude of AB. Okay, in order to find the magnitude, you have to have the direction first. So you got 5, 3. 5, negative 3, I'm sorry. We already did that in part A. So how do you find it? Do y'all remember? Right, it's the square root of both x and y squared. So 5 squared is 25, Negative 3 squared is 9. So it's the square root of 34. Can you simplify 34? Does a perfect square fit in? You can list them again. 1, 4, 9, 16, 25. Is there a perfect square that fits evenly into it? No. So then that's it. The magnitude of vector AB is 34. So this is what you know about AB. It traveled 5 right, 3 down, and it has a length of root 34. Okay, now let's go the other way. What if I asked you to find BA? Do you think the answer is going to be different than AB? Yeah? Okay, try it. You think the answer is going to be different? Okay, somebody asked, can I just flip them? Well, you're going the other direction, right? A vector, I'm asking how far am I traveling on the x-axis and the y-axis? Well, to get from A to B, I needed to travel 5 right and down 3. If I'm going the other way, to get from B to A, I'm going to travel 5 left and 3 up. Correct? I'm still, the distance, the x value is the same. It's just you're going the other direction. Right? So to get from A to B, to get from 4 to 9, I'm going to travel to the right 5 spots. If you go the other way, from B to A, I can't go right 5. If I'm going from 9 to 4, which direction do I have to go? Left 5. Right? And on the y-axis, if I'm going from negative 1 to 2, I'm going to go up 3. Do you see what I'm saying? So it matters. So you're going to go this way again, which in your math, if you want to do that, that means you start with A. So 4 minus 9, which is negative 5. You start with A. That's why I've got it written this way. You start with whatever ends. So if you're going from, and then you're going to say, okay, I'm going to take A, which would be 2, and subtract negative 1. 2 minus negative 1. You're going to do the math on it. What is that going to give me? 3. It's easy. So to get from B to A, I need to go left 5. And it makes sense. 9 left 5 is 3, right? And then you're going to go up 3. All right, let's try another part. This is the last section. Okay, given vectors, this time I'm going to give you vectors, not, these were just points A and B. Now I'm going to give you vectors. Here's vector U, which is going to be called 3, 1. V, which is negative 8, 4. And W, which is negative 6, negative 2. Okay, and we're going to perform a few different operations with it. So the first thing I'm going to ask you is to add the two vectors together. So if you want U plus V, these are very simple. U plus V. So in other words, I want to take 3, 1 and add to it negative 8, 4. Where would I be at? In other words, if I'm going to travel 3 and then negative 8 more, where would I be? Take the x's and put them together, and be at negative 5. Now then, take a look at the y's. 1 plus 4, where would I be? At 5 units on the y. I'm going to travel 5 on the y. Okay, let's try number 2. This time I want u minus v. U minus v. U minus v. Try it. Okay, so that would give me 3, 1 minus negative 8, 4. So if you're gonna subtract, 3 minus negative 8 gives you 11. 1 minus 4 gives you negative 3. Now let's try number 3. 3u plus w. 3u plus w. Give that one a shot.